Okay guys, good morning. So we are going to today continue with what we talked about with the last lesson about graphing linear equations using a table. We're going to look at some today that are going to be a little bit different, that are going to require us to change our x values based on what the coefficient of x is. So let's start with a little review of what we did yesterday. So yesterday, or the last lesson I should say, we looked at graphing using a table, and the x values we started with were -2, -1, 0, 1, and 2. Now, could we always fit those values on our graph? Well, it depends on the size of your graph. -7 units. Yours, I suggested maybe to do 10 units. But even in some cases, we had some values that wouldn't fit, and we're just not going to graph them. Okay, they're going to be outside of our graph, and that's going to be fine. We know that by using arrows at the end, that eventually our line will get to that point. So I'm going to substitute -2 for x. So -3 times -2 is 6, plus 2 is 8. I'm going to substitute -1 for x. So -3 times -1 is 3, plus 2 is 5. 0 is always an easy one because it's just our constant, right? 2. This is going to be -3 times 1 plus 2, which is -3 plus 2, which is -1. And then -3 times 2 plus 2, which is -6 plus 2, which is -4. So if we look at the y column, right, we've got 8, 5, 2, -1, -4. All those y values are decreasing by 3. And we said the reason why is this. It's that coefficient of x. So let's plot those points. Well, unfortunately, -2, 8 doesn't fit on my graph, which is fine. Again, if you have a 10 by 10, it'll fit. I'm going to start with -1, 5. I'm going to plot 0, 2. I'm going to plot 1, -1. And I'm going to plot 2, -4. Okay, and I'm going to get my ruler, and I'm going to connect these points with our straight edge ruler. All right, I'm going to use arrows to show that it's continuous, meaning eventually it will get to -2, 8, even though that's all the way up there, and all the other values, and we're going to label. So again, once you've plotted your points from your table, we're going to connect them with our ruler. We're going to make sure we use arrows to show it's a line and not a line segment. And we're going to label the equation on the line. Okay, so let's take a look at something like this. So I'll set up my table. And the question that I would ask to my class is, what's going to be the problem if I use -2, -1, 0, 1, 2? And we start thinking about it, and we start substituting, and we realize that if we use -1, we're going to get a fraction or a decimal. And we realize if we use any odd number, we're going to get a fraction or a decimal because we're taking half of our x value, right? And we can take half of any even number and get an integer as our product, but half of any odd number is always going to give us something and a half, right? Half of 7 is 7 halves, or 3 1/2. Half of 11 is 11 halves, or 5 1/2. So we're going to say, well, could we plot fractional values? Well, we could, right? I can approximate where 5, 1/2 is, but it's going to be a little bit, it's not going to be perfect. So what we're going to do is we're going to say, well, what kind of values could we use that will give us integers? And someone raises their hand. They say, well, even numbers, right? Because if I take half of an even number, it will be an integer. I say, great. So we're going to modify our approach a little bit today. And I'm just going to use even numbers, right? And 0 is an even number, and negative numbers can be even also, right? They can be even and odd. So when I substitute here, I'm going to get half of -4 minus 4. So half of -4 is -2. -2 minus 4 is -6. I get half of -2 minus 4. Half of -2 is -1 minus 4 is -5. I get half of 0 minus 4 is 0 minus 4 is -4. And look at the pattern, right? -6, -5, -4. We would expect that the next one would be 1 minus 4, which is -3. And then 2 minus 4, which is going to be -2. Now, sometimes, if someone's really observant, they're going to say, well, yes, we go back to the do now, and we said, well, since this was -3, this was decreasing by 3 each time. And I say, okay. And we say, well, it's not decreasing by half, it's decreasing by 1. And I'll say, well, yeah, that's true, but that's because the x values are decreasing by 2. So if the y values are increasing by 1 and the x values are decreasing by 2, that's where the 1 and the 2 come from. So again, this is not something that we want to spend too much time on now. I don't want to confuse people, but if sometimes the wheels start turning in our head and we're like, we try to make that connection. The connection is that when you have a fraction, the numerator represents the y change, which in this case is 1, and the denominator represents the x change, which is 2. Now, once we get to slope in a few days, it's all going to kind of be unwrapped and it's all going to make sense. All right, so let's start graphing these points. So I'm going to plot -4, -6, okay, which is down here. I've got, this is -2, -5, right here. I've got 0, -4. I've got 2, -3, and I've got 4, -2. Now, something I could do if I wanted to is I can say, where would the next point be? Well, to get from one point to the next point, I'm going up 1 and 2 to the right. So if I want to place another point, I can do it there. I can go up 1 and 2 to the right. I'm going to get my ruler out. I'm going to start connecting my points. I'm going to draw those arrows to show it's continuous, and I'm going to label my equation right on the line. All right, let's take a look at this one. So I'm going to set up my table. Right, that's -3/4 x plus 3. Okay, so now we're going to have to ask ourselves the same question. We're going to say, well, -2 through +2 isn't going to work so well, right? Because none of those values except 0 will give me an integer, right? If I try -2, -3/4 of 2 is going to be 1.5, plus 3 is going to be 4.5. So that's not going to work so well. And 1 is certainly not going to work well, right? If I use -1, it's going to give me 3/4 plus 3 is 3 3/4. So I'm going to say, what kinds of numbers, if I multiply by 3/4, will give me an integer? Well, what are we doing when we multiply by 3/4? Well, we're taking 1/4 of a number, and then we're taking 3 of those. We're multiplying it by 3. So if I'm taking 1/4 of something, I want that number to be a multiple of 4. And someone will always say, we use multiples of 4. Now, what are multiples of 4? 4, 8, 12, 16, 20, and so on. So if I'm going to want 0 here and 4 and 8 here, it would make sense to use -4 and -8. So someone always asks, they get confused and they say, how do we know what multiples to use? And you just look at the denominator. If the denominator was 5, we'd use multiples of 5. If the denominator was 3, we'd use multiples of 3. More often than not, the denominator is going to be, if there's a fraction, it'll be either a 2 or a 4. So let's take, again, the coefficient of -3/4 means my y value should decrease by 3 when my x values increase by 4. So now we should be able to plot those points, or at least some of them, right? I can't fit -8, 9, unfortunately. I can fit -4, 6, which is going to be up here. I can fit 0, 3, which is down here. I can fit 4, 0, and I can't fit 8, -3. So let's take our ruler out and connect our points. And we're going to label our equation right on the line, right? Y equals -3/4 x plus 3. All right, let's take a look at this one. So I think we looked at one like this with the previous lesson, but we're going to take a look at a couple more that go a little bit deeper. What am I going to do here? Well, every equation that we've seen has been in the form y equals, and that's pretty much always the way we want our linear equations, at least for this year. Next year may be a little bit different if you graph using intercepts, but for the most part, we always want these equations solved for y. I don't have it solved for y, so we're going to think back to our lesson on literal equations, and the primary reason we did that lesson is for scenarios like this. So I'm going to divide both sides by 2. So 2y divided by 2 is y. 8x divided by 2 is 4x, and -6 divided by 2 is -3. So let's remember, when we're dividing a binomial, that just means two terms, right? The two terms are 8x and -6 by a constant. We're dividing each of those terms by the constant, right? In other words, I'm dividing every single piece of this, every single term by 2, which gives me y equals 4x minus 3, and that's what we would graph on the table, right? I don't need to do that one because we did it with the last lesson, but that's just a reminder that's going to set up the next one. All right, it's really important that we understand how to do this, okay? What's different about this one than the last one? Obviously, 5 is not evenly divisible by 2, okay? So what are we going to do? And again, this is going to throw back to something we did closer to the beginning of the year. What happens if we solve an equation and the answer is a fraction? We leave it as a fraction, okay? We're never going to want a decimal. We're never going to want a mixed number. In general, guys, mixed numbers are something you almost never see in algebra. For the next couple of years, you're not really going to see too many mixed numbers. Decimals we see here and there, but for the most part, at least when we're doing algebra and geometry, we prefer fractions. So let's divide everything here by 2. So 2y divided by 2 is y. What's 5x divided by 2? Well, what we're going to do is we're going to say 5 divided by 2 is literally 5 divided by 2, or 5 halves. And we're going to leave it like that with the coefficient of x. And then negative 8 divided by 2 is negative 4. Again, guys, very important that we understand this. Okay, so we're doing 2y divided by 2 is y. Okay, fine. 5x divided by 2 is 5 halves x. That's exactly how we're going to leave it, and negative 8 divided by 2 is negative 4. So if you had one where it was, let's say, 3y equals 5x minus 12, you would divide everything by 3. 3y divided by 3 is y. 5x divided by 3, we would just leave as 5/3. So again, if it is not evenly divisible, you leave it alone, just like when we solved the equations. And then negative 12 divided by 3 is negative 4. Okay, so this is your now try. So I'm going to do you a favor here, and I'm going to do the first step. So this is similar to the last one, where we're going to divide everything by 2. 2y divided by 2 is y. 3 is not evenly divisible by 2, therefore we just leave it as 3 halves. And then negative 8 divided by 2 is negative 4. So this is really what we're graphing. So if the denominator is a 2, what kind of values are we using? Well, we're using even numbers, just like we did with that first one. Negative 4, negative 2, 0, 2, and 4. Okay? So now you're going to do this, okay? So you're going to sub those in. You're going to find the coordinates, and you're going to list out those coordinates, and then you're going to graph it. So when I substitute negative 4, 3 halves of negative 4 is negative 6, minus 4 is negative 10. 3 halves of negative 2 is negative 3, minus 4 is negative 6. 3 halves of 0 is 0, minus 4 is negative 4. All right, let me fix that last one. You guys are all saying, wait, that's not right. 3 halves of negative 2 is negative 3. Negative 3 minus 4 is negative 7. We have 3 halves of 2 minus 4 is 3 minus 4 is negative 1. And then we've got 3 halves of 4 minus 4. So 3 halves of 4 is 6 minus 4 is 2. All right, so let's graph the values that we can. So obviously I can't fit negative 4, negative 10. I could just squeeze in negative 2, negative 7 down here. And then I've got 0, negative 4. I've got 2, negative 1. I've got 4, negative 2. I'll take out my ruler and connect those points. Make sure we draw through the last point. You don't want to put an arrow on a point. It's kind of a subtle thing, but it does look kind of odd if you put your arrow like on your points like that. Okay, so just to be clear, let's draw through the point and then we'll label. Now, someone always asks, well, what do we label? Do we label the original equation or the new one? The short answer is it doesn't really matter. Mathematically, they're actually the same equation. But from a technical standpoint, we really should label the original one because that's what we were asked to graph. So if this was a Regents and someone's looking at your line and they're saying, where did they get y equals 3 halves x minus 4 from? They weren't asked to graph that. I don't think they take off a point, but just for the sake of, what's probably more correct, I would label the original equation. Okay, guys, so there's your homework. Graph on separate planes, meaning I should see 3 different graphs. I should see not one graph with the mishmash of these 3 equations. Number 1 will be on a graph. Number 2 will be on a different graph. Number 3 will be on a third graph. For number 1, obviously the coefficient is negative 1/2, so we're going to use even numbers. Number 2, the coefficient is 1/4, so you're going to use multiples of 4. And if it bothers you that it's 2 plus, you can put the plus 2 at the end. I just wanted to show you something a little bit different. Number 3, you're going to divide everything on both sides by 3. You will not get a fraction. So for number 3, you're not going to get a fraction, but I am going to guide you and say divide everything by 3, see what you get, and then graph. As always, guys, questions, you post them on Google Classroom with your uploaded homework, and we'll take a look at it.